All right, so I just want to go over these videos, these molecules with you real quickly. Okay. Alrighty, so we have, this is carbon dioxide, and we have an O, which is in red, and an O in red, and we have the carbon in the middle. You'll see they're all in one line, so this is 180 degrees. All right, so again, it's going to pull in this direction, it's going to pull in this direction, but because the same amount that's pulling in this direction as this direction is going to make this a non-polar molecule based on symmetry. Okay, so it's 180, it's linear, and it's non-polar. Okay. And the 3 category here, we have a 3. Okay, so this is like your boron with your Cl, Cl, Cl. Okay, you will notice that it's in the plane, so that's why it's called trigonal for a triangle, and it's planar because it's all in a plane. It's two-dimensional. It's like flat. Okay, these bond angles are 120 degrees, 120, 120. And so it's trigonal planar. And again, if all 3 items are the same, then it would be non-polar. Non-polar. Okay. So if I change one of them, say I made one blue, they're not all the same. And so that would make this a polar molecule since they're not all the same. So this would be polar. Okay. Now the example that we used in class was BCl3, and so since they were all 3 the same, that cancels out based on symmetry, and therefore it is non-polar. Okay. 4 category. So the 4 category looks like this. It's tetrahedral, all right, because it makes a tetrahedron, all right? And so the bond angles are, doesn't matter which way I hold it, the bond angles are 109.5, 109.5. Okay, 109.5. Again, if all 4 items are the same, it would be non-polar. If I pluck one off, and now I made them not all the same, then because they're not all the same, it would be a polar molecule. Polar molecule. And any polar molecule would possess a dipole moment. And there we have it. Okay, so tetrahedral, when they're all 4 bonds, and 109.5 degree angle, and non-polar if all 4 are the same. Okay. When you change one of them, and I just took that out, and this is my lone pair. Okay, this is my lone pair. So you know, oh, it doesn't sit flat. Okay, so it's like a pyramid that you would have out in Egypt. All right, and so its base is 3, so that's why it's called trigonal pyramidal or trigonal pyramidal, if you like that better. But here's my lone pair on top. Okay. Again, my bond angles are going to be approximately 109.5 because this lone pair is going to push down and make these slightly less than the 109.5. So that's why we say approximately. Okay. We have 4 items attached to that central atom, and so therefore those 4 items are not all the same, and so this would be a polar molecule. And so last but not least, we have 2 lone pairs. And so we have those 2 lone pairs and we have 2 bonds. Okay? And that's how it looks. Alrighty. So again, the bond angle is approximately 109.5. Okay? It's slightly less because of these lone pairs. We still have 4 items attached to our central atom, so approximately 109.5. The structure is not flat. It is not linear. It is bent. It is bent. So you can tell that it's bent. When you look at that, it's bent. Okay? And all 4 items are not the same, so it is a polar molecule. Polar molecule. Okay? So those are the 4 shapes. So we have bent. We have trigonal pyramidal. We have tetrahedral. We have trigonal planar. And we have linear, which are all in a line at 180 degrees. Those are your 5 shapes that you need to learn for Lewis dot structure. Okay? If you have any questions, please let me know.